Most Python code operates on data, but it turns out you can also write Python code that operates on other Python code. This is called metaprogramming, and it is one of the highest leverage things you can do when creating software. Coders who use metaprogramming are able to rapidly create tools and components that other developers simply cannot. It is like the difference between riding a bicycle and flying a jet. You not only travel faster, you can go places you simply could not reach at all with a lesser vehicle. There is a reason that the world's best software extensively uses metaprogramming. You can find examples of metaprogramming in the source code of the most successful Python libraries. And there is a reason that these extremely powerful software tools heavily use metaprogramming. Let's look at an example to illustrate this. Imagine this function, which makes an HTTP request to an API endpoint. It's very simple. When you call this function getItems, it has just one line calling request.get with the URL. And then it returns an object representing the response from the remote server. Suppose the remote API has an intermittent bug, so that most of the time it works great, but it turns out that 1% of requests will fail with a status code of 500. This is the HTTP status code that indicates an uncaught exception or some similar error on the remote server. And you cannot really make the API team change it right away. You can ask them to fix it, and maybe they'll eventually get around to it. In the meantime, you just have to deal with it. So what do? Here's the key. You realize that if you make the same request again, it has a 99% chance of succeeding. So you modify your getItems function to retry up to 3 times. This reduces the failure rate from 1 in 100 down to 1 in 1 million. Here's what the code looks like. We're not going to go into this in detail. You can screenshot this and study the code later if you're interested. Just know that this will detect when the remote server returns a status code of 500, and if it does, it will retry the request up to the maximum number of tries. So this is great. This effectively solves the problem because it reduces the failure rate down to an acceptably low level. Now imagine you need to do this more than once. Imagine your application does not have just this one function that's affected by this issue. Imagine it has many functions which make requests to different endpoints of this API, all of which have the same problem. How can you capture the retry code in an easily reusable way? The best way to do this in Python is with a metaprogramming tool called a decorator. The code for it looks like this. Again, we're not going to go through this function and explain how it works. Take a screenshot if you want to study it later. But what it does is generalize the retry algorithm that we had previously integrated inside the getItems function. It extracts that algorithm and encapsulates it in a form that we can easily reuse with other functions and methods. You do this with a special syntax in Python using the @ character. This is what it looks like. We use the original version of getItems, the one-line naive version, but notice on the line just prior to the def, we say @retry. And the great thing is we can apply this to any other function or method. If we have different callables for different endpoints, we can easily apply the same pattern to all of them. Even better, this retry logic is fully encapsulated in the retry function. You can change the number of retries, implement exponential backoff, or make any other changes you want all in one place. All decorated functions immediately reflect your updates. There's something else going on here: ease of reuse. Metaprogramming often allows you to implement solutions to extremely complex and difficult problems in a way that people can easily reuse. This retry function and the decorator that it implements, it's really rather advanced code. Not every Python developer will be able to write code like this, but you used it to solve a problem facing the entire team, and you packaged it in this tool that is instantly usable by everyone. Not only does this boost your contribution to the team, it also affects your status in the workplace. Your presence on the team has amplified everyone's productivity and systematically improved the reliability of the entire application in a way that everyone recognizes right away.